What's up, guys? Hopefully you enjoyed that Ohm's Law practice worksheet. I'm sure you did. It was really a good one. But what I want you guys to do next is what I'm about to tell you. I want you to take some notes in your lab notebook, all right, about series circuits. So grab your lab notebook, pause the video for a second, go find your lab notebook so we can take a couple quick notes on series circuits and what series circuits are and what's special about them and why we'd like to know about them. And then after we do that, right, after you take a couple notes on these series circuits, I have some practice problems for you guys to check out involving series circuits. So depending on how long the Ohm's Law practice problems took you, and then how long it takes you to do these notes, you may or may not have time for the first set of series or practice problems and or the second set of series practice problems. We'll see. But what I'm gonna do now is just open up a whiteboard really quick, find a fresh page in your lab notebook, and let's talk about series circuits. So right at the top, I'm just gonna write series circuits. You can see what you share here. Yeah, I want everyone to see. Why are you telling me that? Getting better with this writing. C-E-I-T-S. Series circuits. So series circuits, we've actually used series circuits quite a bit because the first three circuits that we made in each of our labs, right? Circuit 1, which looked like light bulb. Circuit 2, which looked like this. And I'm sure you guys are tired of seeing these. Just kidding. Everybody loves to see circuits. And circuit 3. Right, all of those are series circuit, right? So this is circuit number 1, this is circuit number 2, this was circuit number 3. Each of those is a series circuit. All right, we have been constructing series circuits for a while now. So circuit 1, 2, and 3 are series circuits. So what makes something a series circuit? How do we know that these 3 are series circuits? So the thing, I'm going to put a little star here so that we know this is important. The big thing that makes a series circuit is there is only one path for the electricity to follow. Just one path. My face is going to get in the way. Move it up here for a second. All right, a series circuit is a series circuit because there is only one path for electricity to follow. So what do I mean by that? Like how do we tell that these are series circuits based on what I've just said? Well, if we look, right, and let's draw this in orange, right? If I look at this circuit, if we say electricity, and this isn't exactly how electricity works, so don't quote me on this, but if we say the electricity comes out of this side of the battery, it goes through the circuit, right, around, and it's back at the beginning. That is a single path. It's the only way that the electricity can go. All right, if we look at circuit 2, goes through the light bulb, goes through that light bulb, and it's back at the beginning. One path. Circuit 3, through light bulb 1, through light bulb 2, through light bulb 3, back to the beginning, one path. In each of those cases, there's only one path for the electricity to follow, so they have to be series circuits. As opposed to circuit 4, right? If we draw circuit 4 here really quick, circuit 4 looked like this. So circuit 4, if we go through here, right, electricity starts here, goes around, and right at this point, right, it can either go down or it can go right. And that's 2 different paths, path 1, path 2, two choices. So it's not only one path, right? It could go around and it could go this through this light bulb and back, or it could go down through this light bulb. So because there's two paths there, this is not a series circuit, right? If you give the current a choice to go different ways, it's not a series circuit. So series circuits, there's only one path to follow. So this, no, it is not a series circuit. Okay, so what's special about series circuits? Now that we kind of know how to define a series circuit, right? It's Alexa thinks I'm talking to her. Alexa, stop. Sorry about that. So what's special about these circuits? There's a couple things. So we could talk about current, voltage, and resistance in terms of these circuits, right? And each one has its own special thing, the three fundamental parts of a circuit. So let's talk about current in a series circuit. In a series circuit, the current is the same everywhere. It's constant. It doesn't change. The current here is the same as the current here. The current here is the same as the current here, is the same as the current here. It's always the same value, right? There's never multiple currents in a series circuit. All these spots, right? If we are in the same circuit, they have the same current. So current is special in a series circuit because it's the same no matter where you are. It's always equal. What about voltage? What's special about voltage in a series circuit? Voltage is special because, and we actually saw this in our voltage lab when we were investigating voltage. The voltage of the components, meaning the light bulbs in our case, is equal to, actually, I missed a word. It's not equal to. The voltage of the components adds to the voltage of the battery. The voltage of the components adds to the voltage of the battery. And we saw that when we looked at circuit 1, 2, and 3 in our voltage experiment, right? We saw, I don't know, maybe we're looking at circuit 2. And in circuit 2, this light bulb had 3 volts. And this light bulb had 4 volts, right? That meant that the battery was 7 volts, right? The voltages of the components, right? If this light bulb's using 3 and this light bulb's using 4, then we know that the total voltage, the battery voltage is going to be 7 because the voltage of the components adds to the voltage of the battery. All right, so current, the same everywhere. Voltage of the components adds to the voltage of the battery. And we could talk about resistance as well. The resistance of each component meaning each bulb adds to the total resistance of the circuit. The voltage of the resistance of each component adds to the resistance of the circuit. So circuit 1 didn't have a whole lot of resistance because it only has 1 bulb. Circuit 2 has a little bit more resistance because it has 2 bulbs. Circuit 3 has even more resistance because it had 3 volts. And that's why we saw current decreasing as we added more bulbs from 1 to 2 to 3, because as we added more components, the resistance of the circuit increased. Right, so the resistance of each component adds to the resistance of the circuit. So those are really the big 4 things that we need to know about series circuit. 1, we need to know that in order to have a series circuit, You need to have something where there's only one path for electricity to follow. We need to know that current is equal everywhere. No matter where you look on the circuit, current's the same. We need to know that the voltage of the components adds to the voltage of the battery. And we need to know that the resistance of each component adds to the total resistance of the circuit. All right. As we add components, we get more resistance. So like this plus that would give us the total resistance of the circuit. Okay, so get this down in your lab notebook. And then what I want you guys to do, there is a worksheet called, it's right here, I have it. Series circuit problems, episode 903. All right, I want you to hop in and try and do that. If you need help with it, right below this video, you should find the solutions to the video solutions to that worksheet to kind of help you out. All right, so if you need help with that, check out the solutions to the series circuit practice problems, which should be in the next video here. All right, but make sure you get this in your lab notebook. I'll be around on Monday to check that to see if you have all that there. All right, I'm going to stop sharing and start working on the solutions to the series circuit problems. Bye.